This video talks about how to draw the Lewis structures. Lewis structures of the compounds can help in understanding physical and chemical properties of the compounds. For example, let's say you have a compound H2CO. The formula tells us the number and the identity of all the atoms, but it does not show the connectivity between the atoms. It does not show how these atoms are connected, or which one is, whether hydrogen is connected to carbon or oxygen. So if you draw a Lewis structure that shows the connectivity between the atoms as well as where all the bonding and non-bonding valence electrons reside. First, we're going to start with the Lewis symbols of elements. We're going to go to the compounds later on. Let's talk about the Lewis symbol of elements first. Lewis symbol of elements represents valence electrons. So what do you have to do? And we have already discussed how to write down the electronic configurations. For drawing the Lewis symbol, you really do not have to write down the electronic configuration, but the reason I am doing this here so that you can practice writing the electronic configurations too. So for example, hydrogen atomic number is 1, means one electron. Electronic configuration is 1s1. Number of valence electrons 1, because this is the valence electron. And how do you draw the Lewis symbol? You put the symbol and you draw the number of valence electrons. That's Lewis symbol. Lithium atomic number is 3. Atomic number 3 means 3 electrons, and we're going to write down these electronic configurations in terms of noble gas. So 3 electrons means helium 2s1. So again, how many electrons are in the outermost shell? 1. So what will be Lewis symbol? This. Beryllium atomic number is 4. Atomic number 4 means 4 valence electrons. 4 electrons, not 4 valence electrons, I'm sorry, 4 electrons. And how do you write down the electronic configuration? Helium 2s2. Number of valence electrons 2. Again, number of valence electrons are in the outermost shell. Outermost shell is 2 here, so how many electrons are there? 2. So how are you going to draw Lewis symbol? 1, 2. Carbon atomic number is 6. Atomic number 6 means 6 electrons. 6 electrons. Electronic configuration will be helium 2s2, 2p2. Now second is the outermost shell, and how many total valence electrons are there? 2 plus 2, 4. And how do you draw symbol? 1, 2, 3, 4. That's the Lewis symbol for carbon. Nitrogen atomic number is 5. Electronic configuration will be helium 2s2, 2p3. Total number of valence electrons 5, and Lewis symbol will be 1, 2, 3, 4. First you put 4 unpaired electrons and then you start pairing up. Oxygen atomic number is 6. It will be helium 2s2, 2p4. Number of valence electrons are 6, and its Lewis symbol will be 1, 2, 3, 4, 5, 6. Now these are the way we draw Lewis symbols for elements, means you just draw the number of valence electrons. Lewis structures of the compounds. For that, we follow the set of rules, or we follow the number of steps. We're going to practice how to write down the Lewis structures of these 5 compounds. For example, let's say draw the Lewis structure of methane. first is count, so it's methane, and first step is count the number of valence electrons. Carbon fourth A group has 4 valence electron. Hydrogen has 1 valence electrons, but there are 4 hydrogens, so 1 times 4, so total is 8. So number of valence electrons are 8. Second step, determine an arrangement for the atoms. Now always place hydrogens and halogens on the periphery because these atoms form only one bond. So arrangement means, so let's put carbon here. Hydrogen has to be at the end. So let's say I'm going to put hydrogens like that. Now this is an arrangement. Step 3 is place a pair of electrons or a line or 2 dots between each pair of bonded atoms. You can also do it like that carbon is in the 4th A group, so carbon has 4 valence electrons. And hydrogen is in the 1st A group. Hydrogen has only 1 electron, so that's hydrogen. So if you look at, each hydrogen has stable configuration because it has 2 around it, and carbon is sharing 1 electron from each hydrogen. So carbon has 8 electrons around it. So step 4 is satisfy the octet. For now hydrogen's octet is 2 and all others should have 8. So we can see carbon has 8 electrons around it and each hydrogen has 2 electrons around it. Let's take the next example, ammonia. So here first count the valence electrons. So ammonia, nitrogen has 5 valence electrons, 3 hydrogens, 1 times 3 because each hydrogen has 8, each hydrogen has 1, so total is 8. Arrangement, you put this arrangement, and then they say place a pair of electrons between the atoms. So let's say I'm putting pair of step 3, I'm on step 3, place a pair of electrons between each atom, and I did that. So now I have 8 electrons available, and how many electrons I'm done using it? 2 here let me draw it quickly again. So here 2, I'm going to draw it like that. So I'm done using 6 electrons, 2, 4, 6, 2, 4 and 6. Now so 8 minus 6 equals to 2. That means I'm left with only 2 electrons. Now satisfy the octet. Step 4 is satisfy the octet for the outer atoms first. These are the outer atoms are hydrogens, and hydrogens, each hydrogen has 2 around it, so each hydrogen is good. It's satisfying the octet. All others need to have 8. So but nitrogen has, so this, we were here, we had this situation, and we were out of 8, we were done using 6 electrons, so 2 are left. So what we have to do is place the remaining electrons around the central atom. So let's say if I put those remaining electrons here, then how many electrons are around nitrogen? There are 8 electrons around nitrogen. Is each and every element has the noble gas configuration? Yes. So this is the Lewis structure of ammonia. I'm going to go back to the last slide so that I can start talking about another example 2. Let me get rid of these things and we'll take another example. Let's say this H2CO. First step, count the number of valence electrons. So H2CO, hydrogen has 1 valence electrons. There are 2 hydrogens, so total 2. Carbon has 4, oxygen has 6. So total number of electrons that are available are 12. Using these 12 valence electrons, we have to show that each and every element has an octet. Then determine an arrangement for the atoms, and again place hydrogens always at the periphery. So let's say if I put it like this, here and here. Let's do it like that. And then step number 3 is place a pair of electrons, either a line or two dots between each pair of bonded atoms. So let's put 2 electrons. So 2 electrons here, 2 electrons here, 2 electrons here. Now satisfy the octet for the outer atoms first. Now here outer atoms are hydrogens and oxygen, and hydrogen octet is already complete. Here and here we can see. Now oxygen, so we have 12 electrons, so how many we are done using it? 2, 4 and 6. So 12 minus 6 is 6. We are left with 6 valence electrons. Now it says satisfy the octet for the outer atom. This is the outer atoms. Right now it has only 2. So that means I have to put 6 more to complete its octet. So is oxygen has 8? Yes. So now I'm done using all my electrons. So let's see how many electrons are around carbon. Around carbon we have only 6 electrons. That means something is now, I'm done using all the electrons, but octet is still not complete. So let me draw that structure here on this slide again. So we were here, C, and this was the structure, and we have the problem here where carbon's octet is not complete. So step number 6 is, if the central atom still does not have an octet, move a lone pair of electrons into to form a double or triple bond. So what it means, you can use these electrons and move lone, because these are lone pair of electrons, in here to form a double bond. So let's look at this. What if we do that? So we already have 2, we move 2 more here, we have this situation now. So now look at it. Oxygen has 8 electrons around it, carbon has 8 electrons around it, hydrogen has 2, this hydrogen has 2. So each and every element has noble gas configuration. Now if we draw this structure in terms of bonds, so 2 electrons make 1 bond. But in between carbon and oxygen, we have 4 electrons. 4 electrons means 2 bonds. And then here are the 2 valence electrons. Again, let's go back to the last slide, and that will be BF3. C2H6, we can discuss it in the class. It's in your worksheet as well. So let's talk about BF3. Now boron is in the third A group, and so it has 3 valence electrons. And fluorine is in the 7th A group, it has 7 valence electrons. 7 times 3 is 21. So total number of electrons are 24. Next, the arrangement will be boron, 3 fluorine. Remember we say hydrogen and halogens should be on the periphery. Then put 2 electrons in between. We did that. That means we use 6 electrons. 24 minus 6 is 18. We still have 18 electrons. Now we're going to satisfy the octet of outer atoms. So around each fluorine, I have to put 6 valence electrons, so that each fluorine has 8 electrons around it. So 6 times 3, 18, and I used all the electrons. I do not have any more electrons. So go that on step number 5, it says if the central atom is in the 3rd row or above, it can violate the octet rule. Boron and aluminum are exceptions. Boron is the exception. Boron is stable even if it has 6 electrons around it. So even aluminum, the same thing. Aluminum is also stable if it has 6 electrons around it. Remember, these two are exceptions. So going back, this one will be the Lewis structure of BF3 because boron still can have 6 electrons.
Made with Doodlecast Pro.